Now we are going to look at the concept of matter. We said that physics is all about studying matter with respect to energy and force. Now, what is matter? Matter is actually anything that has what? Mass and occupy space. So every object that we are seeing today, even those that we cannot see, like your wind or breeze or air, mixture of gases, they are all what? Matter. Provided that thing has what? Mass and occupies space, that thing is regarded as what? Matter. So anything that has mass or weight and occupies space, we refer to it as what? As matter. Matter can exist in various forms. We may have matters that are what? Solid forms of matter. Forms of matter. Matter can exist in solid form. Matter can exist in solid form. Examples of matter in solid form. You have your eyes. You have the marker I'm holding now. The board we are seeing now. They are all solid. Matter can also exist in liquid form. In liquid form, examples of matter in liquid, we have water, we have kerosene, we have the petrol, we have diesel. These are matter in liquid form, and matter can also exist in gas. Gas, or we call it the what? The gaseous form. Matter that exists in gas, we have oxygen, we have hydrogen, carbon 4 oxides. These are matters that exist in what? In the gaseous form. Now, when we make mention of what matter is, we said matter is anything that has mass or weight and occupies what? Space. Most times people tend to confuse between mass and the weight of a body. Since we are introducing physics, we have to clarify this. What is actually the mass of a body? When we are talking about mass of a body, we are actually talking about what? The quantity of the particles or the quantity of the molecules that make up that body. That is what actually the mass of a body is. The amount of particles or the amount of molecules or the amount of atoms that make up a body is actually what the mass of the body is. The weight of a body is the force which the mass exerts. Weight of a body is the force that the mass itself exerts on its what? Support. As a result of what? Gravity. So, this is a slight difference between what? The weight of a body and what? That of the mass of a body. In most times, calculations, they tend to look at them and use the same equipment occasionally to try to derive them. Why? Because there's a connection between what? The mass of a body and the weight of a body. What is the connection between mass of a body and the weight of a body? It's simple. The mass of a body and the weight of a body. Now let's look at that. Weight of a body, weight is equal to what? Mass times gravitational what? Acceleration. That is what, and gravitational acceleration is relatively what? Constant in a given place. So we say that weight W is equal to the mass represented by N, and gravitational acceleration is represented by G. So because this G is constant, where our what? G is relatively what? Constant. We say it's relatively constant. We can now determine the value of our what? Our W from our what? Our N. We can also determine the value of weight from the value of what? Mass. But actually, mass and weight, they are quite what? Different. Now, in an examination condition, you may be asked to write the difference between mass and weight. We are going to look at the difference between mass and weight. Differences between mass and weight. One of the difference between mass and weight, so the quantity of particles that make up the body is what? The mass. While for the weight here is what? So you can see that this is the quantity of the particles that make up the body, while this one is the force which this quantity of the particles that make up the body now exerts, is what? The weight. The second difference is that mass is a scalar what? Quantity. Mass is a scalar quantity. Scalar quantity means quantities that have only magnitude. They are not described by direction. But our weight, it is a vector quantity. Vector quantities are quantities that have both magnitude and direction. They have both size, amount, and they also are described by what? Direction. Another big difference between our mass and the weight of a body is that the mass of a body does not change. From place to place, the mass remains constant, does not change. So if you take the mass of a body from Nigeria and you carry it to America, the value remains the same. You take that mass to the moon, the value remains the same. Take it to the pole, the value remains the same. To the equator, the value remains the same. But for the weight of a body, the weight of a body varies. It changes from place to place as a result of what? The variation in the gravity. So weight varies. Its value changes or varies from what? From place to place. Due to what? A change or variation in gravity. Because gravity varies from place to place, weight of a body also varies from place to place. Another difference, which I may not decide to write, concerning weight and mass, is that the mass of a body, the unit is kilogram. The mass of a body, the unit is kilogram. And while the weight of a body is SI unit, is Newton. Also, another difference between mass and weight is that the mass of a body can be measured with the beam balance or the chemical balance or the lever balance. But our weight is usually measured with what? A spring balance. In our next class, we are going to look at other topics in physics.